Show the complete mechanism for the Friedel-Krafts reaction between benzene and chlorocyclohexane. Okay, so the first step is the formation of the electrophile. You have your Lewis acid, step one. Step one. You have your Lewis acid AlCl3, and you have chlorocyclohexane, Cl, attached to a cyclohexane. It's not showing, but yes, you do have 3 lone pairs on your chlorine, on your chlorocyclohexane. So what happens is that one of the lone pairs on your chlorine, it complexes with the aluminum trichloride, and what happens is this. What happens is, it complexes with the aluminum trichloride, so now the bond between that chlorine and that carbon, which represents 2 electrons, goes to the chlorine as a lone pair, and this is what you get. Now you have AlCl4, you have a negative charge on aluminum, and in the process you have formed this. You have a positive charge there. It's not showing, but yeah, you do have 2 H's there. You do have 2 H's there. You do have 2 H's there. 2 H's at that carbon. 2 H's at that carbon. And you have 1 H there. Hence the plus charge on that carbon. Now we have the electrophile. And now the benzene ring will attack the plus charge on that carbon. So step 2. Step 2. This is where benzene shows up in the picture. H, and you have your electrophile. I'm not going to spell out all of the H's. You have a plus charge there. Yeah, even though benzene is aromatic, it doesn't want to react. It's going to grab that highly reactive carbocation. Okay, so yep, that pi bond there attacks the plus charge on the carbon, and this is what you get. Now at this carbon you have an H, and at this carbon now you have a covalent bond to the cyclohexane. Yep. What happens when benzene does that? What happens is now you have a plus charge at that carbon on the benzene ring. So the aromaticity has been breached. Of course, you still have that AlCl4. Right? Alright, and step 3, this is what happens. So the starting material in step 3 is the product in step 2. H and the cyclohexane, and you have the plus charge there. Okay, so you did produce AlCl4 minus in step 1, so it re-enters the picture. So AlCl4 minus, you have a minus charge on the aluminum. So benzene is unhappy because the aromaticity was lost. So what happens next is the AlCl4, one of the Cl's, grabs the H, and that bond between the carbon and the H goes between that carbon and that carbon, and now you have this here. Aromaticity is re-established. That third pi bond is now back there. The H was grabbed by one of the Cl's on AlCl4, and now you have the cyclohexane attached to the benzene ring, and in the process you produced HCl, and also you regenerated AlCl3.